Good evening, sir. Good evening, Shamari.
Hey, afternoon, how you doing?
Sir, I came to look for you yesterday, but you weren't there.
I was
Young
there
lady
from
said
I
showing.
I was at school from about 8:40 yesterday. Yeah, about 8:40 yesterday, and I never left school until about 3 o'clock.
Well, when you stepped out, she said she didn't know where you went.
What time are you looking for me?
That was after 11 minutes to 12.
I was in a class. I had three classes yesterday. So I had three classes on campus yesterday, and then one in the evening. I had a class 8 o'clock. Sorry, 9 o'clock to 11. I was in the same room that you did the exam. Um, um, the calculus one exam, 306B. I was in that room for a class up until 11. Then I went downstairs into the physics lab for class 11 to 12. I was helping some students rather with SB 11 to 12. And then I went over to block A for a 12 to 1 class. And then I went further on block A, 3 or 4 for a 1 to 3 class. At which point in time, it was way too tired because I was going from 11 o'clock, from 9 o'clock straight until 3 o'clock, no break. So that, all right. So no, so I was saying that it's a planting, so they done plant, say, no, I'll come tonight. Say, no, walk with no book, walk with no pen, say, no, do nothing. So I'm planting.
From I left home this morning for work, I have not arrived back at home as yet. I'm still on the road. It's not a
Okay.
planned thing.
You normally go home for class?
Yes, every day.
Oh, okay, okay, okay.
Unless I get home late. I didn't expect to be on the road until this late.
Mm-hmm. All right. So,
Sir, good evening, sir.
hi, Michael.
Did I miss
Uh,
anything?
not yet. I'm about to say
Okay.
it.
Okay.
I'm very disappointed. Um, with the mid semester. Hi guys, can you hear me?
Yes, sir, but yeah, echo.
Okay. I don't think I'm echoing anymore now though. Hmm. All right. Yes. So before I got dropped, I was saying that I'm very disappointed with the mid semester, and I feel somewhat abused by it. A number of you went online and used math solvers to solve the questions. I don't think you guys knew that I also have access to those math solvers. And I don't know what you guys thought was going to happen, that I wouldn't have figured it out. And when I saw a common trend, I wasn't figuring it out, but I was a little concerned about something, and I saw something that says to me, how long is it going to take for you to recognize what has happened? And when I went back and looked, I really am very disappointed with the who. Very disappointed. I decided to give it a mid-semester this way because in Calculus 1, a student asked if I could give the mid-semester that this way. And I said, what the heck? You have enough to do on Edicassoft. Let me just do it. And besides, I didn't want to do it in a class time because I didn't want to take up my time, because I wanted to use my time to teach. So I thought to myself that this would have been, something similar. But yeah, I'm very disappointed. So the mid-semester will have to be re-administered, and it has to be administered under exam conditions. I cannot use these grades. When I say that I'm disappointed, it's like you're building a relationship, and you built a relationship, and having built a relationship, you feel like you have a trusted relationship with this employer, employee, co-worker, best friend, your confidant, whoever it is, and then something happens that turns you away from that trust, and allow you to feel whatever it is. I could have said something in a WhatsApp group from before, but I chose to do it through this medium so that when I upload a video, those who are not here can actually hear it, to the point where I said that I'm not teaching anything else. I'm just done. I am done. I feel betrayed, and I don't know if you thought that I was naive, not pick it up. It's unacceptable. It tantamounts to cheating, and it was done by people who I didn't expect, because you all I expect to pass the exams, not a bad group. Really isn't a bad group. So there was no need to try and beat the system that way. So congratulations. What it is that you've done is to have etched in my mind what transpired, and going forward, I will not be lenient in that regard. And I will go with the standard procedure of doing it on the exam conditions. So I said to Astenil that I was hoping that everybody would turn up to class, because I'm actually in the process of writing a new paper that I wanted to administer in class today, but she's unavailable. So what you need to do is, I have no part to play in it. You guys need to let me know which day next week you are available for the mid-semester. And it has to be a time that is conducive to my time, so that I can sit and watch. Or if you so choose, we could all come to the main campus and have this exam done face to face. The choice is yours. I will not have a part to play. All I will say is that the mid-semester will have to be done prior to the end of the week. Failing that, if nobody decides to do over the mid-semester, whatever grade that you guys get as a punishment is going to be divided by 2, and I will use that as your mid-semester grade. And I'm serious about it. And I'm very serious about it. So if you got 50%, your mid-semester grade is going to be 25%. If you got 100%, your mid-semester grade is going to be 50%. So you all decide when it is supposed to do. The way I feel, I started preparing a question or questions, and I just kiss my teeth. Maybe that's why the computer dead on me, because I started watching a movie. It was fully charged, and then I unplugged it. I never remember to plug it back in, because I just wanted to drown out my sorrows. So you all can decide when it is that you want to do the stuff. There is one other topic that I need to look at. I'll spend about an hour with you guys to look at it. I can't even spend the whole time with you guys, the way I feel, honestly. Really feel hurt, disappointed, betrayed. I don't expect students who are finalizing or in their third year of a degree program could do something like this. But anyhow, I'll get over it. So I will do a 1 hour of teaching, and present the material to you and call it an evening. So give me a minute, please. right. Sorry about that. I'm back with you. Let me find here.
Sir, if you're speaking, we're not hearing you. I see you're unmuted, but if you are
No, man,
speaking, sir.
no, man, I had closed out the document from this computer and I had to, the one that I was using before that died, so I had to wait until I get a little bit of charge. Now I'm trying to get the information and it's taking its own little time. I guess it vexed me, it's taking its own little time to go around to get the info. So I'm here waiting for
Sir,
it to.
the grades that we have that you're disappointed in, can you share them with us?
I could. It's not the grades that I'm disappointed in.
I know you're disappointed in us, but
Okay.
Sir, and I am asking if you could do the last question because I was a struggling question. I didn't know how to do it. So
Good evening. I was just able to join.
We're doing utterly. Are you seeing my screen? I'm not sure if I'm sharing. Oh, yes, I'm sharing.
yes, sir. See the screen.
All right, so this is my final topic for the semester. It's not anything, it's not a biggie. It's not a biggie. It can be a biggie, but based on what I'll be doing with you, it'll be enough. So we're looking at first order differential equations. I'm not going to go through, I don't think I'm going to go through the second order. And if I do go through second order differential equations, it may just be one question. That's if I do it. My main aim really is just to look at the first order differential equations. First order differential equations. So it says the general solution of a differential equation is going to be of the form f dash of x, which is equal to f of x, or I can give it dy by dx, which is equal to y. Could also give it dy by dx, which is equal to y. It means that the first derivative is going to be equal to the function. That's what it is. So I'm going to give you a function, and you will have to get that function into one of those orders. So it means if I give you the first order differential equation, you're going to be given something with dy by dx. Yours is going to be the responsibility to find what y is. I may give you something which is f dash of x. Your responsibility is to find what f is. So it means that you have to do some integration. So that's what the differential equations is all about. So it says it can be found by using direct integration. Can be found by using direct integration. So I'm going to be looking at some general and particular solutions, of my first order differential equations. So in a nutshell, it says to just find the particular solution of the differential equation dy by dx is equal to 4x minus 2. Find the particular solution of the differential equation dy by dx is equal to 4x minus 2. And it is given that y equals 5 when x equals 3. So when you're given additional information to the question to tell you that given that y is equal to 5 when x equals 3, it means that they want you to go down to the particular solution. What do I mean by that? Remember when I was doing double integrations with you, and I said to you that when I do the first indefinite integration, I must have a c. And then when I do the second indefinite integration, whatever variable I'm integrating that by, I'll have the first c, the first constant of integration as cx or cy, and then the second one is just c alone. All right? Because I don't have any additional information to the function because it's indefinite. So I have to put my constants of variation, c. In this case, when I find a particular solution, when I find a general solution, the general solution is going to be like me doing an integration with just, it is like me doing an integration, an indefinite integration, where I'm going to include my c. The particular solution is me evaluating what that c is. So when I go to the particular solution, I want to go to the original question, original function that I started off with. All right, so let's go. dy by dx is equal to 4x minus 2. dy by dx is equal to 4x minus 2. So please note that conditions must be given for you to evaluate the particular solution, as I said before. Otherwise, you can only determine the general solution. So the general solution is what you can always determine. If they need more information from you, they give you additional stuff for you to evaluate a particular solution. So let's just look at the solution to this. It says dy by dx is equal to 4x minus 2. See here, dy by dx is equal to 4x minus 2. I'm putting this function over 1. I'm putting that function over 1. So it says, remember that when you have two fractions separated by an equal sign, you always cross multiply. So if you recognize what it is that I'm doing here, separating my variables. But sir, I never knew you could do that. Yeah, man. So I'm using my variable separable. I am separating the variables because my aim is to keep all the x's one side and then all the y's on one side. Because I want to get my general solution, y equals something. Just like when I ask you to differentiate something, I give you the function y equals something. Or if I ask you to integrate something, I give you the function y equals something. Yeah. So that's what I want to end up getting. Y equals something. You don't have to be y. It could be f of x equals something. All right. So when I have two fractions separated by an equal sign, I'm going to cross multiply. So I'm going to have my variable separable. I'm going to be separating my variables in a way where I cross multiply dy by 1 is when you give me dy. And dx times 4x minus 2 is simply 4x minus 2 dx, which is here. Now, if you look at it, you would agree with me that I have only y on one side of the equation, and on the other side of the equation, I have only x. So y alone exists on one side of the equation, and in the other side, I only have x alone. Do you see what I'm talking about? Do you agree with me? Do you disagree with me?
I agree.
Thank you. So now that I have my y alone on one side, and now that I have my x alone on one side, I'm going to integrate. So what I'm going to do is to put the integration sign in front of my dy. Now remember, when I was teaching the integration, I said to you that we don't say the integral of 1 dy. We just say the integral of dy because it's redundant and it is understood that is when there's a 1 there. And I'm dropping my integration sign in front of this 4x minus 2 as well. So, see it right here, the integral of 1 is simply written as dx and not 1 dx, right? Now, I'm going to, so when I integrate dy, I'm going to get y. When I integrate dy, I'm going to get y. See the y right here, so? When I integrate dy, I'm going to get y. And when I integrate my 4x minus 2, I'm adding 1 to the power divided by the new power. So this is going to become 4x squared over 2. See it right here, so? 4x squared over 2. And then when I integrate negative 2, I'm going to get negative 2x. Remember, that's why I put this in pink. Remember, negative 2 is really negative 2x to the 0. But you know that anything raised to the power of 0 is 1. So I don't have to write x to the 0 because it is understood that it is 1. But to bring across a point, I'm going to just highlight that there's an x to the 0 there. So yes, there's an x value. How do I go about this? By adding 1 to the power and dividing by the power. So 0 plus 1 is 1 divided by 1, which is the same thing. So I'm going to end up with minus 2x. I must put my c, my constant of integration. This is now my general solution. My general solution is going to be y is equal to 2x minus 2, 2x squared minus 2x plus c. Any questions so far regarding the general solution?
Sorry, no.
No, sir.
No, sir.
All right.
Well,
And then no.
Sir.
Uh-huh.
So what did you took the integral of both sides?
Yes. Yes.
All right.
And then no. At the top of the question, it says, we need to find a particular solution of the differential equation. It didn't ask me to find a general solution, but there is no way I can find a general solution, the particular solution, without first finding the general solution. So I must find the general solution first so that I can do my substitution in order to achieve my particular solution. So if you look at the conditions given, it says when or given y equals 5, when x equals 3. Y equals 5. This is going to be equals to 5, and the value of x is going to be equals to 3. So when y is equals to 5, x equals 3, my y is equals to 5, and my x is 3. Anyway, in the function equation, I see x, I put 3. So this is 2 times 3 squares right here, minus 2 times 3 here, plus c. So therefore, you'll recognize that I'm evaluating c. So 5 here, 3 is 9 times 3 is 18, negative 2 times 3 is negative 6 plus c. And 18 minus 6 is going to give me 12. So I'm going to have 5 is equal to 12 plus c. I'm subtracting 12 from both sides. So I'm going to have 5 minus 12 equals c. So c is going to be equal to negative 7. So my particular solution is me now substituting this c equals that for negative 7. I take your questions. So my particular solution now is telling me exactly what it is that I started off with. My original function was y equals 2x squared minus 2x minus 7. Differentiate that for me and tell me what you get, please. Differentiate y equals 2x squared minus 2x minus 7 and tell me what you get.
4x minus 2.
What was the question? 4x minus 2. So the differential equations is really me moving from the differential to go back to where I started off with my original function. So all along, I have been teaching you to start with the original function and either differentiate or integrate. Now it is that I'm giving you the differential and ask you to go to the original, where it is that I would have started. And where I would have started in order to reverse the process Because to go from y to dy by dx, I differentiated. In order to move from dy by dx to y, I have to integrate. How you know that, sir? Because one is the opposite of the other. If the forward movement is for one, that means the backward movement is going to be for the other. Does that make sense?
Yes, sir.
All right, now. So you would have seen, if I look at my general solution, and I differentiate my general solution, this is a constant. And when I differentiate a constant, I get 0. So if I use my general solution, I would have still got my 4x minus 2. But my particular solution now can give me much more information than compared to the general solution. Right? So sometimes the question may ask you to find the general solution. Sometimes the question may just ask you to find the particular solution. But of course, remember, if the answer to find a particular solution, you must first have to find a general solution. So let me just run through quickly again. You're given the differential. Dy by dx is equal to 4x minus 2. And it says given y equals 5 when x equals 3. I need to find a particular solution. So in order for me to find a particular solution, I must first find the differential, the general solution. I must first find the general solution. Sir, why is that called differential equation? It's called a differential equation because I have dy by dx is equal to a function. Now, this is first order differential equation. That's why I have FODE, first order differential equation, dy by dx. I can give you a second order differential equation. This is going to be d squared y by dx squared, or f double dash, right? As I said before, if you have a second order differential equation, it simply means that you have to integrate the function twice. That's all it means. You have to integrate the function twice. Do they? Yes. And sometimes you are given a multivariable function that you have to go work and twerk. But if you follow the instructions, you shouldn't be off too badly. All right, and then now I'm gonna set my function, my differential, to be over 1. Then I'm gonna cross multiply. Whenever I have two fractions separated by an equal sign, I cross multiply. When I cross multiply, my dy is going to be multiplied by 1. And my dx is going to be multiplied by 4x minus 2. Now, I'm going to look at this, and I will recognize that in here, all my function in here is going to be related to x. The 4x minus 2 is going to be related to x. So that's why it is grouped with the dx. And my dy is really the rate of change of y. So I'm just going to have the dy alone on one side. Once I'm able to separate my variables, the next thing is to go and integrate. I cannot integrate if I have the xy on something like that, or the yx. We're not doing a multivariable integration in this case. Though we can do it because you know how to do the multivariable integration. Multivariable integration is really the double integrals that we've been doing. All right? And then now when we integrate, of course, remember we add 1 to the power divided by the new power. The integral of dy, we don't say 1 dy, we just say dy is going to be y. And the integral of course, similarly, the integral of dx is going to be x. So this x dx is telling me that every function in this parentheses has to have an x. So I each of this x to the 0 here, just a point of clarity to show that there is an existing x with a 0. The only reason not seeing it there because anything raised to the power 0 is 1. So now, when I have my 4x minus 2 to integrate, I'm going to add 1 to the power divided by the new power, so that becomes 4x squared over 2. See it right here. I'm going to integrate -2, I'm going to get -2x. And then I have to put the plus c. Sir, why? Because it's a constant of integration. I don't know what else is out there. Something else is out there. And then when we would have gotten that, it says given that y equals 5 and x equals 3. Anywhere in the function you see y, you put 5. And anywhere in the function you see x, you put 3. So my general solution is going to be 2x squared minus 2x plus c. And then I'm going to substitute in the value of x and the value of y in the function. And then you look at all of that, I'm going to get my c to be equal to -7. So my general, my particular solution is going to be 2x cubed minus 2x minus 7. It's called a particular solution because it is the actual equation that was given. So we would have unsolved the mystery. Look unto me if you agree. You see the original function down here? The differentiated function up here. You have the differentiated function. We'll work on work until we get this down here. Any questions?
So we can say that this is define what the constant is.
But for the particular solution, yeah, the information given is to find what the constant is.
Okay.
Work with me. I'm giving an example for you to try on your own. Even to separate the variables. And if you don't get it fully the first time, it's not a problem to me. Really not a problem because we'll work on it. dy by dx, it says find the particular solution of the differential equation. Remember, in order to find a particular solution, we must first find the general solution. It is from finding the general solution that we're going to extract additional information. So it is that we can find, the particular solution. So it says dy by dx is equal to 3x squared minus 1. dy by dx is equal to 3x squared minus 1. Given that x is equal to 2, when y is equal to 1. Obviously, would you like me to scroll up?
Yes, sir.
I'm stepping out for 2 seconds. Obviously.
Still working, sir.
Say it again.
Finish, sir.
Still
Okay.
working.
Oh, still working. Okay, here I finish. All right. Look over for my Simon, please. What ticket for C, Simon?
Sir, I got 2.
Good job.
So you can scroll up for me, please.
Sure. Right there?
Yes, sir. Wait, before that. Right there.
Can I move or still working?
So I need to see what y and x values are, please.
Y equals 2, x equals -1.
Y equals 2, x equals minus. Sir, I think my answer is a -2.
No, I got a +2. Let's go.
Alright.
So we're going to put the 3x squared over 1, 3x squared minus 1 over 1. We'll cross multiply. We're going to end up with, why did this go though? We're going to cross multiply. We're going to get dy is equals to 3x plus 1, 3x squared minus 1 times dx. Then we integrate here. We've just separated the variables, variable separable, and we are going to now be integrating. So when I integrate, the integral of 1 is just written as dx or dy for that matter. So I'm going to get y equals, I add 1 to the power divided by the new power. So this is 3x cubed over 3 minus x plus c. So my general solution is going to be x cubed because the 3 cancels. So I'm going to have x cubed minus x plus c. That's the general solution. The particular solution now is when I substitute the conditions to the function. And the conditions are given y equals 2 when x equals -1. So 2 is going to be equals to -1 cubed minus a -1 plus c. And c is equals to 2. C is equals to 2. So my particular solution now is going to be y equals x cubed minus x plus 2. Let me know how you feel, how you stay.
Mr. Mess up, sir. The question.
Say that again.
Me kind of mess up on the question, sir. I didn't differentiate what the top, the 1x. So
But you're
that's
not
where
you're not differentiating though, you're integrating.
integrating, sir.
Mm-hmm.
Integrating. I messed up right there.
Okay. Somebody else coming in. What were you going to say?
I was saying I saw my mistake. I
Okay.
didn't integrate either with the 1 because I was thinking that it's already 1, so I don't need to I don't need to integrate with the x to the 0. So that's where I went wrong.
Okay. So now you know. Any other comment? Okay.
Sir, I'm gonna have to log off now though because I'm about to move.
No problem. You'll get the recording.
Alright, sir.
Take care. All right, here goes another question.
Hold on, I think I have host. Give me a second.
No, yeah, you're the host. Yeah, that's true. I have example 3 now projected. I'm gonna ask you to give it a try. Example 3.
Alright, sir, I made you host.
Okay, thank you.
Alright.
Finish?
Yes, sir.
What do you got for the answer?
The equation.
What's the general what's the general equation?
Oh, the general equation, I got 7x to the fourth over 4 minus 2x cubed over 3 minus 5x plus c.
And what's the particular solution?
7x to the fourth over 4 minus 2x cubed over 3.
All right, he got dropped. Anybody was agreeing with what it is that he has?
Yes, sir, but I'm not really sure.
What's the value of C?
So I got -1.
Correct. Very nice. -1. All right, two more. All right, I think he's back now.
Alright, so we have to rewrite the equation, right?
Yes, to get the particular solution. All right, Shamar, you're back now. Did you get C to be -1?
Yes, sir, that's what I got.
All right, good job. Are there any dissenting voices right here as it relates to this question? I'm going to give you about two more because there's nothing more to this, as I promised you. Any questions?
There's a question about the definite double integral. So with that, when you find the second integral, you just so plug in the limits.
The other upper and lower limit, yeah.
All right.
Right, I'm going to try with this question. See if you were listening to what I was saying earlier. A straight line with gradient 3 passes through the point 2, -1. Find the equation of the line. Find the equation of the line. Any idea?
We just use y equal mx plus c and plug in those formulas.
Okay,
And
go ahead
then-
and do it. Go ahead and do it, Shamar. Quick and fast.
Sorry, can you scroll back up a bit, please?
Finished, sir.
What did you get?
Y equal 3x minus 7.
Math equals 3x minus 7. Okay. Anybody that's tried it? Along with Shamari, he gave me a suggestion. I don't know if he's right.
Still working on it.
It's still working. All right. Waiting on your Shamari too. Shamari, very good.
I think I said negative 5.5 gets the C. Let me put it right.
Okay. Anybody else?
No, sir.
Okay. All right. So I just taught you a while ago about differential equations. So dy by dx is equal to 3 because it says that it has a gradient of 3. So that's 3 over 1. dy times 1 is going to be dy is equal to 3 dx. If I integrate that, I'm going to get y is equals to, add 1 to the power divided by the new power. Add 1 to 3, you're going to get 3x. And that's plus c. And then when x is equals to 2, y is equals to negative 1. So that's negative 1 is equals to 3 times 2 plus c. Negative 1 is equals to 6 plus c. Negative 1 minus 6 is equals to c. Negative 7 equals c. So therefore, y is equal to 3x minus 7. That's what you got, Shamari?
Yes, sir, that's what I got, but then I didn't work it. The CHC max rate.
Which is a point. So that's a point I'm gonna I'm bringing across to you now. So when you're doing CXC maths, you are also doing some differential equations. What will give you the fundamental way of doing it, which is finding the equation of a line in this regard. So I put that question there because I want to just show you how you were doing some differential equations long time. I never did know. Was this exactly what I taught you a while ago for differential equations? Yes, no, maybe so.
Yes, sir.
Right, so just to show you the flexibility of the mathematics. Remember, that's where I started earlier. Now. I started to say that the gradient is given by dy by dx, or it can be given by f dash of x. And if they say that the gradient is 3, you work the little magic. Work the little magic. Easy as 1, 2, 3. All right. I'm going to give you a little longer equation. So I don't want you to think that the question can be, is going to always be short, so to speak. And when I say short, meaning like 2 terms. You see, I get x to the 4th plus radiated. Yeah, you can get those stuff. All right, I'll give you 3 minutes to work this one. Finish?
Yes, sir.
Yes, sir.
What did you get for your answer?
Well, I got one.
Same.
What's a particular solution?
Y equal x to the fifth over 5 plus 2x squared over 2
No.
minus x
Plus
plus 1.
C.
Okay. So whatever it is, we need to be looking at what we have. We're trying to separate the variables. We're putting all the x's on one side and everything else on the other side. Let me ask a question. Do you feel comfortable with this yet?
No, sir, not really.
Yeah. Anybody else?
And repeat, sir.
I was asking if you feel comfortable, but somebody said they don't feel so comfortable yet.
Yes, sir. That one got me off, sir. The gradient. I forgot dy over ds is also the gradient.
All right, I'm going to give you one more on this one, and then again, liquid at 6. So try get this one, Mikey, because um there you go. Take your time and go through the process. we stay.
I'm still working, so make a mistake, so I go back over.
Okay. All right, no problem. Just let me know.
Yes, sir.
Okay. And what did you get for your answer?
I got C equal negative 21/4.
Okay, very good. What about the rest of your class though?
How much?
Got that as well, sir.
Good job, good job, good job. Simon,
So
Rosalie,
what was the answer, sir?
yeah, man, check the chat. I responded to you.
All right.
Simon, Otterly, all right.
Sir.
What's your answer?
Sir, I got the, well, I didn't get it, so
You got it, but you didn't get it. I don't understand that.
I got negative 13/4. So I'm trying to see where I went wrong.
Look to see if you have what I have.
Yes, sir.
You see the mistake, or you have what I have there? Simon?
Yes, sir. I'm looking.
Oh, you're looking. Okay.
Sir, any particular reason why I never cancel the threes and the twos?
Not really, because in the final answer, I think I did I cancel them. For the practical solution, I cancel them right here. If I see it here, I do the cancellation right there. Oh. So I'm waiting on you to move on.
Yes, sir. I saw where I went wrong.
Okay. All right. Life is not always going to be that easy. And I'm going to work through one of them with you. Life is going to be sometimes a little an edge. So for example, it says, find the general solution of the differential equation y times dy by dx is equal to x. The separation of the variable there is not as straightforward as the ones we have been doing. Let me see you take an attempt, all of you. Take an attempt to separate the variables for me. To separate the variables so that you have all your x's on one side and all your y's on another side. Quick and fast. As soon as you separate the variables, let me know.
Sir.
Yeah, man. You hear me?
Yeah.
Mhm.
So dy square equals x square.
dy square. But why would you get a square though? When I only give you dy. Remember, you know, what's the aim of the game? The aim of the game is to get what? dy squared or y?
Why?
Y, yeah. So you're going in the opposite direction. You're going in a direction where it is that you are differentiate something to get d squared y to come back down to y.
So
Because the general solution is limit y equals something.
easy one too. So.
All right, try it again for me. I give you 2 minutes this time.
Yeah. So
All right. What did you get this? Okay, let me start here. You recognize that you can't just do a one thing, a one shot way like we did before. We had to do it in 2 steps. We had to do it in 2 steps. Step number 1, we recognize that the y is y over 1. So the numerator is y times dy, and the denominator is going to be just dx. Can you see that?
Yes, sir.
Yes, sir.
Mm-hmm. And then we're going to cross multiply both of them. And then we're going to get y dy is equal to x dx. So this one is a different form of the variable separable. The variable separable, we are separating the variables. You notice I have the y on one side with everything else with the dy. And on the other side, I have everything with the x and the dx. And then now I can go ahead and do my integration. When I integrate y, I'm going to get y squared over 2. When I integrate my x, I'm going to get my x squared over 2. It's an indefinite integral, so I must have my plus c, like we have been getting. What I did right there was just to multiply through by 2, so that them cancel out. So I can have now y squared is equal to x squared plus 2c. And based on the conditions, c is going to be equals to let me ask you, is 2c the same thing as c? If yes, why? If no, why? Is 2c the same thing as c? If yes, why? If no, why?
Yes, sir, because that's what you have right there, sir.
And 2c the constant is the same thing as c the constant, don't?
Yes, sir.
So what I'm saying to you is whether or not whatever value we get for c, that value of c will come out based on the conditions given if you were asked to find a particular solution. Are you following me?
Repeat that, sir.
I'm saying whatever value you get for c will come out based on the conditions that we substitute in the differential equation. You see, everything that we've been doing so far, I'm saying to you, if it is 2c or 3c or 4c or 5c, whatever c it is, based on the conditions that they give you, when you substitute it into the function, you're going to get the same value. The same value of c, that is. Do you agree with that?
I think so.
No, I don't think you think so. Let me ask. Is 25 a constant?
Yeah, yes, sir.
Is 5 a constant?
Yep.
Sir.
Yeah. So whatever the constant is, it don't matter if I multiply 20,000 by 3, it is still a constant.
Oh,
It really doesn't matter what I multiply by, it is a constant. So a constant is a constant. You remember I was teaching you integration, and I said to you, there's a law that says the integral of say x squared plus 2x plus 3 is the same as the integral of finding of x squared, then the integral of finding 2x, and the integral of finding 3. Anybody remember that?
Yes, sir.
Yeah, man. So it is an integral. So it doesn't matter what it is that we're doing, as long as we find the integration of all the points or all the terms, you're going to end up with the same answer. So let me just show you something quickly because I don't think you guys remember, and this is important. Watch your screen. So if I say to you, find the integral of x squared plus 5x plus 6 dx, it's the same thing as finding the integral of x squared dx plus the integral of 5x dx plus the integral of 6 dx, don't?
Yes, sir.
Yeah.
Good. So when I do that now, I'm gonna have x cubed over 3 plus c. Do you agree with that first one?
Yes, sir.
Sir.
Plus 5x squared over 2 plus c plus 6x plus c. So I'm going to end up with now x cubed over 3 plus 5x squared over 2 plus 6x plus c plus c plus c. But if you do the calculation one shot, you're going to end up with x cubed over 3 plus 5x squared over 2 plus 6x plus, and a 1c, that's all right. When if you do the calculation one shot.
Yes, sir. 1C would all right.
Right. But based on me breaking it up, don't a 3c's you ever get?
Yes, sir.
So c plus c plus c, the constant is just going to be equal to 1 big C. It's still a constant. Right? So that's the point I'm making right here. 2c is equals to c. How you feel? No answer?
Feeling good, sir.
Yeah, man, because the truth of the matter is, I just say it down, you know. I mean, I can give you why. All right. All right. Let me do one last one. One last one. And I don't expect you to. Ah. Whoa, 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 whoa. All right, I'm gonna do one last one. Because I wanted to see that life sometimes is this is the final one for the evening. Final one for the evening. Make good use of this. I don't think you will find this difficult if you follow what it is as I have been doing. Um, yeah. All right, do that for me, quick and fast. Or we stay?
So,
Mm-hmm.
of y equals 5xy minus 2x squared y plus c.
Oh, you even answer. Y equals, say it again?
Y equals 5xy minus 2x squared y plus c.
Interesting. What did you get for the when you separated the variables? You remember we need to get all the x's on one side and all the y's on one side. When you did that, all of that, what you get?
Then we have to do that, you know, sir.
Same way, so.
Trouble then, man, sir. So hold on, then. Go walk up high top, then we miss something. Hold on, go walk up high top.
When you say go up at the top, what do you mean?
Previous example.
Previous example, Lord. That one? Then I still had to get the x on one side and the y on one side. Yeah, man. Because remember, the point I'm making is that I can't integrate with respect to x, but I still have a y on that side. So it's not like I'm doing a multivariable integration. So I have to separate my variables. So it's really a variable separable that I'm doing. So the first order of the day is to separate my variable. The first order of the day is to separate my variable. My variable must be separated before I can go ahead and do what it is that I'm supposed to be doing. So let me just show you how I would separate my variable here. Um, I have that there. And then I would say dy by dx is equals to y times 5 minus 4x. Would
You
I
know,
have
sir.
separate? Yeah, go ahead.
I just figure out, you know, sir.
Yeah, man.
Say for factor.
And then what we're going to do now? Multiply by 1 over y to both sides. So when I multiply 1 over y to both sides, dy by dx. I automatically get rid of the y from that side. So on the left hand side, that's going to have 1 over y dy by dx is equal to 5x minus 4. And then sorry, 1 minute. Let me just go and stop that. Yes. So, all right. So I drew that thing there. So because I want to show you something, I was going to do a step, but I know some of you are going to be lost. So I'm going to just read out. I'm going to just read from here. So, and show you. So I wrote just now dy by dx is equals to y into 5 minus 4x. And then I can put that over 1. If I cross multiply, I'm going to have dy is equals to y times 5 minus 4x dx. Tell me that you agree with that one.
Agreed, sir.
And then if I multiply by the 1 over y now, that cancels that. So that's going to have 1 over y dy is equals to 5 minus 4x dx. Now, what I wanted to show you here is if I did this, I would get 1 over y dy is equals to 5x minus 4x. It's not 5x and it's 5. Why am I having 5x? Dx. And then when I integrate that, what do I get? When I integrate that, what do I get? Can I call this? All right, when I integrate 1 over y, what do I get? Look back at your, remember, you know, how do I do this?
I screw over 2y.
No, man. You have to get the
Oh.
foundation, man.
Oh, y over.
No, man. No, man. No, man. You forget the foundation. When I integrate 1 over y, what me get?
1 over y.
What I differentiate to get 1 over y? Guys, I know I taught you calculus once.
I'm sorry. But the quotient those that in
I always say something on is 1 over x.
That me just do a session LNY.
LNY, man. LNY. See, when I forget the stuff, there's LNY. Thank you, sir. So it's going to be LNY, and I'm going to call it the absolute value of y. Why am I calling the absolute value of y? Because you remember you can't take the negative number of ln, I mean, no, the log, you can't find the logarithm of a negative number. The logarithm of a negative number does not exist. So instead of just saying LNY alone, I'm going to call it ln the absolute value of y. But yes, man, when we're doing little school mathematics, we say when you differentiate ln x, we get 1 over x. Remember, you know, we're reversing the process, you know. We're reversing the process now. So we have to think and think wide. So yes, it's going to be lny. And then when we integrate 5, we can get 5x minus 4x squared over 2 plus c. My ear silence like you don't agree with me.
I agree,
I agree with you, sir.
All right,
Sir,
good.
hold on
Yeah.
a second. So why -1? Why to the power of -1?
Very good.
This is the same as lny.
When you differentiate it, yes.
Yeah. So you get the 1 over y.
Because I thought you were going to go somewhere just now. Because if I have side work, if I have y to the minus 1, and I'm integrating that, remember the rule says to add 1 to the power and divide by the new power. So what we're going to get, when we add 1 to the power, we're going to get y to the minus 1 plus 1 divided by negative 1 plus 1, which is really y to the 0 over 0. That 0 is problematic in the denominator. So that's why the integral of this is just ln y.
Oh,
Make sense?
yeah, man.
Good. And then now, my final thing is, whew, I can't get, remember the question wants us to find the value of y, not ln y. Do you agree with me that the question asks us to find y?
Yes, sir.
So if we leave our answer as ln y, we're not finished the question yet. So I have to take the anti-ln of both sides. And when I do that, I'm going to get y equals to e to the 5x minus 4, no, 4 over 2 or 2.
2x, sir.
Yeah, 2x plus c.
2x squared, sir.
2x squared, sir.
Yeah, thank you, sirs. So I'm going to end up with y equals e to the 5x minus 2x squared. I'm sorry, but that plus c is not necessarily there, but it is here, plus c. So you see, it is the same thing that we've been doing, except that this, some teachers will tell you that and it's not wrong if they say to you that this 1 over y that we're multiplying by is known as the integrating factor. It's not a problem. The name is not really important, you just know. But if you were to be preparing for your exam and you see something talk about the integrating factor, yes. So I am multiplying something throughout the equation, talking about a factor, so that I can rationalize my function in a way that it comes seamless. That's what I would have done. I would have multiplied by the 1 over y. The 1 over y will be known as my integrating factor. We do the question the same way, we do the integration the same way. It's just that for the final answer, the man them never given never answer for that people answer no ln. The man them say, yo, we want to find the value of y. In order to do that, I'll have to do something else. What do I have to do? Is to take the anti-log of that. And then I get an exponential function. Any questions?
No, sir. Sir?
Go ahead, please.
So as it relates to the mid semester, you say we're gonna do over, right? It's gonna be on the same topic.
Yeah. It should be the same thing. I'd go and add, I may add something more to it, but I mean, it's going to be on anything that you're preparing for the exam now. So yes, generally the same topic. I can't say it's going to be on the same. I'm going to give you a different version of the question. Yeah. Yeah. I don't think I'll put a differential equation on it because Aston is not here and shouldn't have gotten the gist of it. Who else is missing? Yeah, Aston alone missing. Utterly gone sleep, so utterly missing too. So,
Sir, I did kind of do that one way. Sure.
well, don't worry about it, my dear. It's not you alone.
So the next thing. All right. So for the last question. So I'm not sure if you can work it out and send it to us because what I really like is how it was done.
Okay.
Also, you say you're gonna share the grade with us.
I can. I'll send an email. I don't know. I don't know if I'm going to do it tonight. I mean, I can't send it off, but I sip in some tea. I just made some tea a while ago. So depending on how I feel after, I can just send a WhatsApp with what they look like.
Okay, sir.
Yeah, but please don't let it happen again. This is my last course teaching you, but hear me out. AI is out there, and a lot of us, myself included, is equipped with my technology, and you guys are technology students, to detect certain stuff. And I'm saying to you, and I want you to hear me out, all of my studies are obtained from the University of the West Indies. Say I want to go back to the university now to do a bachelor's in MIS. And at some point in time, they can see that I was supposed to do a project, but what I did was to copy some of this stuff and call it my own. The university can rescind, to take back, to make null and void all of my qualifications that they would have given to me from before. It is within their powers to rescind all of that. So me can say on one side, say, Chona can go on, me still have my degrees from UNO. But life has a way of getting back to us. I decided not to leave Excel, so I want to go to UTech. And UTech said, oh, incidentally, we need a transcript. And I go over to you and say, yo, I need a transcript from XYZ. The transcript is anyway blank because they would have rescinded my stuff. So if I get a blank transcript, there's no way UTech is going to employ me. You know, a quick story. One of our students did something and there was an error on our part. And we said to the student, there was something that was misprinted on your certificate. Come back, present it to us so that we can change and give it the correct stuff. Some glitch went on. And the student don't turn up. And it so happened, I was CCCJ coordinator, so happened that I got a telephone call from India to verify the student's qualification. It is out of my ambit to verify qualifications. I have to go to the registrar. And when I called the registrar, I said, Registrar, I have Shamari Grant on the phone. Not Shamari Grant. I have such and such a company on the phone trying to get some information about Shamari Grant to verify his degree. And I so come and hear the story and they said, transfer the call to me. And the registrar says, the student did not graduate with a degree named such and such. The student has a degree XYZ. You know, so when we say that, so the student don't get the job. This honestly cannot take you anywhere. The student reached all the way in India to get a job. Never knew that India would have called Jamaica to verify. I never knew of the situation until afterwards. The registrar called back to say, you see, this honestly don't pay off. So I'm saying to you students, in all that you do, you have to be credible. You have to be honest because That's the only way that is going to take you across this place. It has a way of coming back at you. And when I saw it, I said to myself, I cannot allow this thing to go unnoticed. So when I sort out to myself in a WhatsApp group, let me know which date it is. And then I will start writing a new paper come tomorrow, God's willing, sleep off this tiredness. And yes, I'll consider sending that question to you, Mr. Michael. Anyhow, big up on yourself. Later.
Okay, sir.
Sir, you know,
Yes,
trying,
sir.
yeah,
Say it again, Atali.
trying to reach out to you. I mean, not respond to me, sir.
When that, but when I reach out to you, when I reach out to you yesterday or the day before.
Yeah, I mean, I call you, sir. I mean, never that get you back.
Oh, you call me back?
Yeah.
Oh, guess what? No, I reached out to you when I was on my way to work. And yesterday, if it was yesterday talking, is yesterday talking?
Sir.
Yesterday, I had a class from 9 o'clock straight back until 3. 9 to 11, 11 to 12, I was doing some SBAs, 12 to 1 other class, 1 to 3 other class. By the time I finished 3 o'clock, I was out of it. And then I had to prepare for a class in the evening. So, Osh, send me a message and then we can link up over the weekend.
All right, sir. No problem. Cool.
Cool.